Alrighty. Today, 4.4a pathway problems. So that's what's on our plate today. Hope you're having a good day. Let's get into it. Here we go. Pathway problems on page 24. 24. Okay. 24, ironically, is also 4 factorial. There's a good one for you. So page 4 factorial. Here we go. Let's show you, I'm going to show you 3 different ways to think about these problems. And the last way is probably the best way. But just want to show you just something out of interest sake, what Pascal's triangle is. It's basically this situation here. Pascal's triangle starts with a 1 at the top, and then it has 1s on either side, and then on all sides. And then what happens is these 2 here add up to 2, and then you put a 1 on the outside again. These add up to 3, those add up to 3, and then you can just build this till the cows come home. That gives you 4, that gives you 6, that gives you 4. And there's a bunch of applications for this in math, and then if you keep going, 1, 5, 10, 5, sorry, that's a 10 as well, 6 and 4 is 10, 5 and 1, and you can keep going till the cows come home. That's called Pascal's triangle. Don't necessarily need it, but you'll see how this pattern, when we go through it this direction, comes out of pathway questions. When it comes to this pattern will come out, as you'll see in the examples. Weird shapes, you're just going to use your counting principle. There are ways of doing this with the last day's repetitious factorial problem that we did. And I'll show you both ways. I'll show you how to do this and this, but B here, the counting way, will be your way to go through it. So the whole goal today is you're going to have a network of streets that you're going to have to get from one particular node to another node. So here it just says moving to the right or down. So you can only move to the right and only move down or right, that's it. Can't go left, can't go up. How many different ways can you get from the top left here to the bottom right here? So I'm going to show you how to do this the counting way, and then I'll show you the permutation way. But the permutation way, in all honesty, works really well when you have a beautiful grid and there's no weird bumps. Like this is weird. That will only work with counting well. Otherwise you have to be extremely on the ball to do it with permutations. Same with weird shapes like this. Those are only going to work with counting principles, and even with this one here. So the counting way is to start here at the node, and just think for a minute, if you were here at point P, we'll zoom in, and you had to get from here to here, there's only one way to get there. Same thing here. There's 2 moves to get there, but there's only one way to get there, because I can only move to the right and down. There's only one path to get there. One path, one path. There's only one path to get along that whole top part. That's it. Same thing from here to go to there. There's only one way to get to that node. Only one way to get to there. One way to get to there. One way. Many moves, but only one way. But here's where things change. To get to here, from there, you could go right and down, or down then right. There's actually 2 ways to get there. And the easiest way to figure that out, or to see that, would be go to the node above it and to the node to the left of it, and 1 is pumping in from here and 1's pumping in from there. 1 plus 1 is 2. To get to here, look what's happening. 1 from above, 2 from here. So this is going to add to 3. And then so on. 1 from there, 3 from there, 4. 4 and 1 is 5. 5 and 1 is 6. So what that 6 means is there's 6 ways to get there. And those 6 ways could be, for example, 1, 2, 3, 4, 5, 6 different paths to get there. But I don't want to sit there and count all those paths. I'm going to use this little technique. So what you want to do is you want to start in the top corner and you want to work diagonally down like this. So now I'm going to work down here. So 2 ways to get there, 1 way to get there. 2 plus 1 is 3. 3 ways to get there, 1 way to get there. 3 plus 1 is 4. 4 plus 1 is 5. Next node would be this one. 3 ways to get there, 3 ways to get there. There's 6 ways to get there. And again, if you're curious what those are, 1, 2, 3, 4, 5, and I don't know where the 6th one is. Let me try that again. 1, 2, 3, 4. I'm only getting 5, but there should be 6. Why can't I get the 6th? Where is it? 1, 2, 3, 4, 5, and 6. I think that's 6, but again, it gets confusing, but I know it's 6. And then from 6 and 4, those add to 10. Now I don't want to count, I couldn't even count 6, let alone 10. But there's 10 ways to get there. And then 10 plus 5, there's 15 ways to get there. And then you kind of keep working, like I said, diagonally across. 6 and 4 is 10. 5 and 10 is 15. 6 and 15 is 21. 10 and 10 is 20. 15 and 20 is 35. 21 and 35 is 56. 56, can't add. 56. 20 and 15 is 35. 35 and 35 is 70. 70 and 56 is 126. There are 126 ways to get from P to Q, only going left and down. Sorry, right and down. The other way that only works for beautiful little rectangles like this would be to think about in the end, it's kind of like the number of ways that you're, in the end, you're going to move 1, 2, 3, 4, 5 to the right, and then 1, 2, 3, 4 downs. And it's kind of, if you think about that permutation, the Ogopogo rule from last day, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 moves, divided out by the 5 repetitious rights and the 4 repetitious downs. And when you type that in, 9 factorial divided by 5 factorial, 4 factorial, there's the answer, 120, 126. But that only works for beautiful rectangular grids. So the counting way is the best way. That's how I do all these personally. Okay? So now to get from A to B, same idea. Here, along the top, to the right. Only 1 way to get there, 1 way to get there, 1 way to get there. To get along there, 1, 1, 1. To get here, 1 and 1 is 2. 1 and 2 is 3. 1 and 3 is 4. And this, like I said, can it work down this way. 1 and 2 is 3. 3 and 1 is 4. 3 and 3 is 6. Very similar to the beginnings of this one. 4 and 6 is 10. 6 and 4 is 10. And now things take a little twist. If you look here, I need to keep panning down like this. Well, if there's 10 ways to get here, to get to this node, there's only one thing feeding into this node. There's nothing, there's 0 ways to get from the top. So there's only one path to get there. So this is 10 again. Almost like how the 1s are dragged across. That 10 is dragged across. Same thing here. The only way to get to this node is down. There's nothing coming in from the right. So that's 10. That's 10. And now I can keep painting this. 10 and 10 is 20. 10 and 20 is 30. 30 and 10 is 40. 10 and 20 is 30. 10 and 30 is 40. 30 and 30 is 60. 60 and 40 is 100, sorry. That's another 100. That's 200. There are 200 ways from A to B. And that's the best way to do these questions. That's how you do it. So, let's do the next guy. Next page, skinny little map. Again, I don't want to drive all those routes, but I'll do it myself. So A to B. 1, 1, 1, 1, one way there, and then 1 plus 1 is 2 because it's feeding in from both directions. Feeding in from here, that's 3, 4, 5. Now what? Remember, I'm here. The only way to get to there is from there, to nothing from the top. So that's 5, and that's 5. But 5 and 5, 10. But then 10 peels down the sides there. 20, 30, 30, 60. 60 ways. Oh, there's my phone. Let's see who this is. Hello.
Hello?
Hello, what's up?
Are you still at school?
I am, yeah.
Till when?
I don't know, till 4:30 or so. Why?
Okay, mom picked me up, but she has to do piano after, so, she's might drop me off at your school, so I just come home with you instead.
Okay, yeah, go ahead, drop off, and then I'll see you here then.
Okay, well, I'll be, there in, 10 minutes.
Okay, yeah, just come into school and come up to the room. I'm just doing video here. So,
Okay.
okay, all right, we'll see you in a bit.
Yeah.
Okay, bye-bye.
Bye.
Okay, next one. Sorry for the interruption there. A little bit of a break. You can laugh at that. That's my son Keith. Okay, here we go. Starting from here. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Now there's a park in the way here. We can't go through the park, although in real life I could go through the park any way that I want, but this question is not real life. So, 2 ways to get there, 3 ways. I'm going to be careful here. 1 from there, 3 from there. So everything's so far so good. The park's not in the way at the moment. 6. And that'll be 7. This will be 3, 4, 5. Very similar. 2 from there, 1 from there, 3, so on. Now 3 and 3 is 6. To get to here, I can come in from there and there. That's 10. No difference yet. The park hasn't had any influence on this yet. This is going to be 15. Now things get weird. Right here, to get to that node, I can't get to there from the top. I can only get from here. So 10 comes across. And then 10 and 15 adds to 25. 10 comes across again. 10 and 25 is 35. Here, the reason I can't do this yet, I can port the 10 over, but I need to know what this number is to pull down. So then this is where this comes in. Well, how do I get to here? Only coming in from the top, nothing from the side. So this is 6. And then 6 and 10 gives me 16. So then 35 and 16 will give me 51. And so from there, now I'm going to continue on with which direction? Let's see. Let's do 7 and 6 is 13. 13 and 16 is 29. And then 29 and 51 gives me, why am I messing up? 29 plus 51 should be 80, right? Yep. 80 ways to get from A to B. Alrighty. Next weird mix. Start here. 1 way to get there, 1 way to get there, 1 way to get there. How about here though? I can only come from the top, nothing is coming from the sides. This is 1. Weird. Here, 1 way from there, 1 way from there, that's 2. 1 way from here, 1 way from there, that's 2. Let's go down to this node. Everything 2 from there, nothing from the side, so that's 2. What about here? Everything from the side, nothing from the top because there's no line there, so that's 2. 2 and 2, this must be 4. 2 and 2, this must be 4. Go to the next node. Nothing from the top, 2 from the side. 2 here again. Just go to each node one at a time, 1 step away. Everything comes from the top, nothing from the side, so that's a 4. But 4 and 4, this has to be an 8. Go to the next node here. Well, 2 from the top, nothing from the side, that's a 2. Good for it. This one, 2 from here, 4 from there, that's a 6. 6 from there, 8 from there, that's a 14. 2 from here, 2 from here, 4, and then 4 and 14, 18. Try it again even, like no, just know this is 18. Try it. Like hide it, draw it again, do it. 18 ways from A to B. So those are pathway questions. Next example here is a checkerboard example. It's the last one before you're off to play. So a checkerboard is an 8x8 board game, good for it, with pieces only able to travel diagonally on the dark squares. If the checker is placed as shown, how many paths are there for the checker to reach the opposite side of the board? Okay, so how many ways could this reach the other side? Well, it's here, it can only go diagonal, it can only go forward. So there's one way to get there, there's one way to get there. Same thing, I can't go back, so there's only one way to get there, there's only one way to get there. But there is, because this is kind of like the Pascal's triangle, or this on its side. 1 plus 1, that's 2. This also must be 1, and then 1 plus 2 is 3, 2 plus 1 is 3, that's a 1 there, and then 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, that's a 1. Here, the only way to get there is from 4. I can't come from this side, so that's 4 again. That's 4 and 6 is 10. 4 and 6 is 10. That's 5. This here, the only way to get there is 5. Nothing comes in from this side. That's 15. That's 20. That's 14. And then the only way to get there is 14 because nothing comes in from the side. That's 34. That's 35. And that is 20. So there's 14 ways to get there, plus 34 ways to get there, plus 35 ways to get there, plus 20 ways to get there. Add that all up, which I should be able to do mentally, but it's been a long day. And there's 103 ways to reach opposite side of board. Good for it. I'm happy for the checkerboard. So feel free, if you need to, play this video again. I think I'll upload this to YouTube and then go from there, and hopefully you had a good day. And then the practice is turn over the page. There's your pathway questions. How many ways to go down and right to get from A to B? Very similar, just practice it. Once you know it, piece of cake. And then there's some checkerboard questions. There's the answers. Should be able to roll through that pretty quick. Again, practice is the only way to get better at it. Hope you're having a good day. Until we meet again.